Hi, it's Fazana again. In this video, part 3 of volume and surface area, higher level, we'll cover some even more interesting exam questions. I hope you've watched parts 1 and 2 and also all my videos on the volume and surface area of all the different 3D shapes. Please do so, then you'll be really comfortable with using the formulae. Let's look at the questions. Okay, a thin-walled glass paperweight consists of a hollow cylinder with a hollow cone on top as shown. The paperweight contains just enough sand to fill the cylinder. Okay, so it's just filling the cylinder. All right. Okay, the paperweight is now turned upside down and calculate the depth of the sand marked X. All right, so you can tell it's the volume of the cone plus the volume of part of the cylinder. Okay, yeah, good. Okay, so as long as you've marked something on the diagram, you can tell you feel in control. All right, let's take the volume of this, the sand in the cylinder. So the volume of the cylinder, which is the sand itself. Okay, let's write the formula first so that we just feel comfortable. Gives you a sense of direction. So you've got pi times the radius is 3 centimeters times 3 squared times the height, which is the 4. Okay, times 4. Okay, and that will give you 36 pi. Okay, let's just assume this is a non-calculator question, so we will just leave it in terms of pi. Okay, so you know 3 squared is 9 times 4 is 36. All right, okay, now it's been turned upside down. You know the height of the cone is 2 centimeters. Okay, good. Okay, so the volume of the cone equals 1/3 pi r squared h. We'll go stick the numbers in. So you've got 1/3 pi times the radius is still 3 times 3 squared times the height, which is 2. Okay. So that's 9 times 2 is 18, and 1/3 of 18 is 6. So we've got 6 pi. So can you tell the volume of the remainder is the 36 pi minus the 6 pi? Yeah? So you've got 36 pi minus the 6 pi, and we'd be left with 30 pi. All right? Yeah? Okay. So again, we've got the cylinder part of it. So we know the cylinder part of it is pi r squared h. Yeah? And we're trying to find the x. So we'll just write pi r squared x. Sorry. It's like you think one thing and you write something else. Equals 30 pi. Okay, all right, the radius is still 3, so we're going pi times 3 squared x equals 30 pi. We can now remove the pi, so we've got 9x equals 30, and divide by 9, so we've got x equals 30 divided by 9. How many 9s are there in 30? 3. 27, remainder 3, so that's 3/9, which is 1/3. Okay, so x is 3 1/3 centimeters. All right, yeah, okay. Can you see an ugly looking question, but as long as you follow the layout, the formula, put the formula, it just gives you a sense of direction. Mark as much as you can on the diagram, and hey presto, it all falls out. All right, yeah, panic not. Okay, let's look at another kind of question. Diagram shows a solid wax cylinder. The cylinder has base radius 2x and height 9x. The cylinder is melted down and made into a sphere of radius r. So the radius will be r. Find an expression for r in terms of x. So we're going to go r equals and then something x. Okay, so let's find the volume of the cylinder first. Okay, the general formula is pi r squared h. Okay, which will be pi. Now again, this is where they test you. You've got to make sure that because 2x is the radius, you're actually putting the whole of the 2x and squaring it. Yeah? And then the height will be 9x. Okay? So we've got 2x squared would be 4x squared. So in terms of numbers, you've got 4 times 9 is 36 pi, and then we've got x squared there times x is x cubed. All right, yeah? So that means the volume of the sphere will be that as well, okay? So the volume of the sphere, the formula, equals 4/3 pi r cubed. So then you know 4/3 pi r cubed must be equal to 36 pi x cubed. Okay? Now looking at that, the first thing I feel comfortable about doing is multiplying by 3 so I can get rid of the denominator. So I've got 4 pi r cubed equals 36 times 3 is 108 pi x cubed. I'll divide by 4. So I'll have pi r cubed equals 27 pi x cubed. Now I can take notice of the pi and divide by it. So we've got r cubed equals 27x cubed. Okay, and we want it in the form of r equals. So now we're going to cube root. So we're going to go r equals the cube root of 27x cubed. So the cube root of 27 is 3, and the cube root of x cubed is x. So can you see you've just got r equals 3x. All right? Can you see how simple the layout is? Yeah? Keep it simple. Just go step by step. Try and make it simpler. Try and sort of isolate the r as much as you can. Yeah? And then once you get to that stage, you're smiling because you can see that's a cube and that's a cube. All right? Yeah? Good. Very good. Okay. A solid is made by putting a hemisphere on top of a cone. Okay, I think it was this question in an exam that actually went viral because it was just such a horrible looking question. People didn't quite know how to go about it. Yeah, so let me try and break it down for you and make sure that you find it simple. All right, so if you get given something like this, you'd be able to maneuver your way around. Yeah, okay. Again, keep it simple. Whatever you see, try and sort of prepare it beforehand. All right, so you've got the total height of the solid is 5x, the radius is x, okay, and the radius of the hemisphere is x. So can you see that would also be the radius, so that would be x, yeah? So you can see up to here, that's only 4x. Okay, so that's the height of the cone, and that's the height of the hemisphere. Okay, yeah, and then we're looking at that, and that's quite thin. Remember, we're going to make sure that whatever we do, if we're squaring it, we're going to put the whole of the 2x. Okay, all right, so we've read that. A cylinder has the same volume, so you know we're going to have that equal sign, so we're going to do that horizontal layout, and the cylinder has that radius and height, h. Find a formula for h in terms of x. So we know we're going to go h equals something or another. Okay, so let's find the volume of the cone first. Yep, so volume of cone. And although they've given us the formula here, so we've got that sense of direction. So we're going 1/3 pi. Now what's the radius? X. So it's x squared, and what's the height? Times 4x. Yeah, let's try and simplify it. So 1/3 times 4 will be 4/3 pi, and then we've got x squared times x, which is x cubed. Okay, yeah, and then the volume of the hemisphere, and we know that's going to be 2/3 pi r cubed. Okay, so we've got 2/3 times pi, and the radius is x, so we've got times x cubed. And if we get rid of these times, we've got 2/3 pi x cubed. So can you see the total volume there? Equals 4/3 pi x cubed plus 2/3 pi x cubed. Now we know 4/3 plus 2/3 would give you 6/3, which is 2. Yeah, so your total volume is actually 2 pi x cubed. Okay, and then it's saying it's got the same volume as the cylinder. Yeah, so the volume of the cylinder, we'll just put the volume of the cylinder, equals pi r squared h. Yeah, and over here we'll write the whole thing. So we've got 2 pi x cubed equals, I should have written it the other way around, so let's write it the other way around, because we need h to be on that side. So we've got pi, and what's the radius? So you've got 2x all cubed h equals that. Yeah, okay, it's my eraser. Okay, so you know that's going to be 8x cubed. Yeah, sorry, it's squared, isn't it? Yeah, okay, just by keep looking at that formula, you suddenly, if you're making a mistake, something's going to jump out at you. Yeah, okay, so we've got 4 pi x squared h equals 2 pi x cubed. Okay, what do they have in common? They have 2 in common, and they've got pi x squared in common. So we're going to remove all that. Okay, so we've got 2, that's all gone, and we've got h equals 2 pi x squared is gone, so we're only left with x. Okay, and then we divide by 2, and we've got h equals x over 2, so we'll just put a half x. All right, yeah, can you see the layout, and can you see why it's so important to write the formula? Because without the formula, I would have continued with the x cubed, but when you're writing the numbers, you've got to be really careful to keep looking at the formula so that you don't make a mistake. So This time you've actually learned from my mistake. You're welcome. All right, good. Okay, last question. The volume of a pyramid is 1/3 times the area of the base times the perpendicular height. VABCD is a rectangular based pyramid, 14 by 8, and it's got a volume of 336. So you can tell that is equal to that. Yeah? X is the center of the horizontal base directly below V. Okay. Work out the angle between VB and the base. So we're looking for that angle there. Okay? Now you should be aware that that is a right angle. Okay? So the minute I look at that, I know I'm using sort of Pythagoras. Yeah? Okay, so we need to find the height, and we need to find half of the diagonal of the rectangle. Okay? So let's start one. We'll go for the height first. Yeah, so we'll just call that H. Okay, so I'm going to calculate H. Okay, but if we've been given the volume, then you can tell we'll be able to find out H from here. Yeah, so all we say is 336, which is the volume, is 1/3 times the base, the area of the base. And what's the area of the base? 14 times 8 times the height. Okay, yeah, and all that comes to 37.3. But you can always just put it on in your calculator. Yeah. So H would be equal to 9 centimeters. Okay, so that was really easy, wasn't it? Yeah? Okay, now let's find the diagonal. So you can tell that, again, it would be a right angle triangle there. Yeah? So those are your two shorter sides, and that's your hypotenuse, and I'm not going to call it H again. Yeah? So we've got the diagonal BD. Okay, so we know we're trying to find BX, and we know it's going to be half of BD. Okay, so let's find out what BD is using Pythagoras. So it will be the square root of 14 squared plus 8 squared, and that will be 16.12. So BX is half times 16.12, which will be 8.06 centimeters. Okay, so that will be 8.06 centimeters. Okay, now we've got our right angle triangle there. That's our H. Take that one off. Okay, that's our hypotenuse. That's the angle, so that's the opposite, and that's the adjacent. So in terms of trigonometry, we've got our O, we've got our A, so it's tan, yeah? So then the angle, BBD, equals, okay, if it's an angle, then we know we're going tan of which angle, and then O over A, so you've got 9 divided by 8.06, and we get 48.15. Cool? Yeah, all right. So this is just going into 3D trigonometry, and I will be uploading a video on more 3D trigonometry questions. Yeah, so look out for it. Okay, well that's all for now for volume and surface area for a while. I hope all the questions were helpful and easy to work through. keep the rhythm and keep working hard, and you'll increase your volume of knowledge and increase the surface area of your brain cells too. Funny, yeah? I really don't understand why my son doesn't laugh at my jokes. I hope you do. And remember, you're in control. Take care. Until next time. Bye.